Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you memory organization of 8051 microcontroller. This is lecture number 10 of microcontroller series. So before I discuss the memory organization of 8051 microcontroller, we know that 8051 microcontroller is based on Harvard memory architecture. In case of Harvard memory architecture, here we use separate memory to store data and to store program. So here we see in the diagram, this is the 8051 microcontroller. Here we use separate memory to store data, that is called data memory. For data memory, here we use RAM. RAM is random access memory. And here we use a separate memory unit to store program, that is called program memory. For program memory, here we use ROM. ROM is read-only memory. Along with this program or data memory, here we use separate buses also. Hence, the CPU can access both instruction and data at the same time. That increase the system performance. Now, 8051 microcontroller memory organization. As I have already told, 8051 microcontroller is based on Harvard memory architecture. So here we use separate memory to store program, that is called program memory, and a separate memory unit to store data, that is called data memory. So first is program memory. So for program memory, here we use ROM, that is read-only memory. Read-only memory is basically used for permanent storing of program or instruction which is executed by microcontroller. Next is data memory. For data memory, here we use RAM. RAM is random access memory. Random access memory is basically used for temporary storing of data or intermediate results. So there is two memory, RAM and ROM. For data memory, we use RAM, and for program memory, we use ROM. So in 8051 microcontroller has both internal ROM, that is program memory, and internal RAM embedded on a single chip. If in any case internal memories is inadequate or insufficient, it means if any case internal program memory or data memory becomes shorter, so we can add external memory to extend the program or data memory using suitable circuitry. Now first I discuss the program memory of 8051, that is called ROM. ROM, as I have already told, is a read-only memory which is used for permanent storing of any instruction, code or program. The original 8051 microcontroller, which is introduced by Intel, having 4 kilobyte of internal ROM. So here we see in the diagram, this is 8051 microcontroller. This is introduced by Intel in 1980s. It is the most popular microcontroller. This microcontroller basically use 4 kilobyte of program memory, that is called ROM, whose address is starting from 0000H to 0FFFH. But in any case, this program memory becomes shorter or the space of the 4 kilobyte program memory is insufficient, then we extend this program memory up to 64 kilobyte by connecting external program memory in 8051 microcontroller. So how we connect, how we use external program memory in 8051 microcontroller, let's discuss. So as I have already told, if we want to extend the program memory in 8051 microcontroller, we can extend this program memory up to 64 kilobyte. And we can extend this program memory in two ways. So first option is we use 4 kilobyte of internal ROM and 60 kilobyte of external ROM. So the total program memory of 8051 becomes 64 kilobyte. So here we see in the diagram, this is the internal program memory that is called ROM of 4 kilobyte whose address start from 0000H to 0FFFH. If we want to connect external program memory, so we connect 60 kilobyte of external program memory whose address starts from 1000H to FFFFH. So the total program memory in 8051 become 64 kilobyte. This is the maximum limit of program memory in 8051 microcontroller. So to get this combination of program memory, we make the external access pin of 8051 microcontroller become high. So to make EA pin become high, we connect this EA pin to plus 5 volt power supply or plus 5 volt VCC supply. When VCC supply is given to a EA pin, this pin become high and we get this combination of program memory. And the second option is we don't use internal ROM of 4 kilobyte. We only use 64 kilobyte of external ROM. So here we see in the diagram, in this case, we don't use internal program memory, that is 4 kilobyte, and we only use 64 kilobyte of external program memory whose address is starting from 0000H to FFFFH. So to get this combination, we make external access pin of 8051 microcontroller become low. It means this pin becomes 0. We connect the external access pin of 8051 microcontroller to ground. So when we connect EA pin to ground, this pin getting 0 and complete external ROM is accessed. Now two important points regarding program memory. Now 8051 microcontroller having 16-bit address bus. So the address of the program memory location, that is 0000H to FFFFH, is stored in 16-bit program counter. Program counter is basically a 16-bit register. It is used to hold the address of the memory location from where the next instruction to be fetched. Once the microcontroller fetch the instruction and use that instruction, the program counter is incremented by 1 automatically. So in this way, program counter maintain the sequence of program execution. So we can say that 8051 microcontroller program memory address is stored in the program counter. Program counter is a 16-bit register that holds the address of the memory location from where the next instruction is to be fetched. Now the second important point is this external storage is addressed or accessed via input-output port, that is port 0 and port 2. These two ports are bidirectional input-output port. In 8051 microcontroller, a pin that is called PSEN pin, program store enable pin, when this pin become high or active, we can read data from external program memory. So in this way, we can use program memory in 8051 microcontroller. So here I explain in brief how we use external program memory. We know that 8051 microcontroller having 4 kilobyte of internal program memory, and if this internal program memory is insufficient or inadequate, we can extend this program memory up to 64 kilobyte. So the first option is we use internal program memory of 4 kilobyte and we add a 60 kilobyte of external program memory. So the address of total memory is 000H to FFFFH. To getting this option, we can make EA pin logical high by connecting EA pin to plus 5 volt power supply. Next option is we cannot use internal program memory. We only use 64 kilobyte of external program memory. So the address of that memory is 0000H to FFFFH. To getting this option, we make external access pin, that is EA pin, become 0. To make EA pin 0, we connect EA pin to ground. So in this way, we can use external program memory in 8051 microcontroller. Now next is data memory of 8051 microcontroller. As I have already told, for data memory, here we use RAM. RAM is random access memory. This memory is basically used to store data temporarily or intermediate result that are generated and used during the normal operation of microcontroller. The original Intel 8051 microcontroller had 128 byte of internal RAM, but almost all the modern microcontroller having 256 byte of RAM. So the total 256 byte of data memory, that is called RAM, is divided into two parts. First part is called general purpose memory area, which is 128 byte, and second part is also 128 byte, that is special function register memory area. So one by one I will discuss both the memory area. So first I explain in detail the memory structure of RAM in 8051 microcontroller. As I have already told, 8051 having 256 byte of RAM. These 256 byte of RAM is divided into two parts. First part is lower 128 byte of general purpose memory area and the upper 128 byte of special function register memory area. So what is lower 128 byte general purpose memory area? This memory area is 128 byte long, whose address is starting from 00H to 7FH. These total 128 byte is divided into three parts. First part is called register bank area. This register bank area is 32 byte long, whose address is starting from 00H to 1FH. This is called register bank area. Next part is called bit addressable area. This bit addressable area is 16 byte long, whose address is starting from 20H to 2FH. Third or last area is called general purpose memory area, or also called scratch pad area. This area is 80 byte long, whose address start from 30H to 7FH. So in this way, lower 128 byte general purpose area is divided. Next is upper 128 byte RAM. Upper 128 byte special function register area is also 128 byte long. It address starting from 80H to FFH. So in this area, 21 special function register is defined. These special function register is related with different peripherals. This area is direct addressable area, or the general purpose area is called direct or indirect addressing area. Now here I explain the general purpose and the special function register area in detail. So first I start from the general purpose memory area. As I have already told, the general purpose memory area is 128 byte long, whose address start from 00H to 7FH. These total 128 byte is divided into three area. First area is called register bank area, which is 32 byte long, whose address start from 00H to 1FH. The second area is called bit addressable area. It is 16 byte long, and the upper portion is called scratch pad area or general purpose area, which is 80 byte long. So first here I explain the register bank area. As I have already told, register bank area is 32 byte long. So these total 32 byte is divided into four register bank: bank 0, bank 1, bank 2 and bank 3. Each bank having 8 register. Each register is 8 bit long. Here we see bank 0 having 8 register R0 to R7, and each register having 8 bit. Same as it is bank 1 also having 8 register R0 to R7, and each register having 8 bit. So here I explain with the help of diagram. Bank 0 having 8 register R0 to R7, whose address start from 00H to 07H. These are the byte address of the bank 0. Next is bank 1. Bank 1 also having 8 register R0 to R7. Address starting from 08H to 0FH. Bank 2 also having 8 register R0 to R7. Address starting from 10H to 17H. Bank 3 also having 8 register R0 to R7, address starting from 18H, 1FH. So here having 4 bank 0, bank 1, bank 2, bank 3, each bank having 8 registers. So the total number of byte is 32 byte. So we can say that register bank area having 32 byte. Every register, that is R0, R1, every register having 8 bit starting from D0 to D7. All the registers are byte addressable register. Byte addressable means we can access a complete byte of the register, and the data transfer between one register bank to other register bank is not possible. This register bank area can be used as a stack area also. Once this register bank area getting full, to store more data, we use scratchpad area. What is the scratchpad area? I will discuss later. And now, out of 4 banks, bank 0, bank 1, bank 2, bank 3, we can select only one bank at a time by using PSW flag register. Now this is the PSW flag register. This is program status word register. The 2 bit of program status word register is used for register bank selection bit. This bit is called PSW 4 number bit and PSW 3 number bit. This stands for RS1 or RS0 pin. These 2 pin are used for register bank selection pin. The combination of these 2 pin define which register bank gets selected. If the combination is 00, register bank 0 gets selected. If the combination of these 2 bit is 01, register bank 1 gets selected. If the combination is 10, register bank 2 gets selected. If the combination is 11, register bank 3 gets selected. If any case, if there is no bank is selected using PSW flag register, so bank 0 is used as a default bank. If any one bank is selected by PSW flag register, so the other remaining 3 bank is used as a memory bytes. And if no bank is selected by using PSW flag register, so bank 0 is used as a default bank. Now second is bit addressable area. Bit addressable area is 16 byte long, whose address is starting from 20H to 2FH. In bit addressable area having 16 byte, each byte having 8 bit, so the total 16 multiplied by 8, that is 128 bit in the bit addressable area. So here we see in the diagram, this is bit addressable area. Bit addressable area having 16 byte. So here is the byte address of the bit addressable area, which is starting from 20H to 2FH. These are the 16 byte of bit addressable area. Each byte having 8 bits, so it having total 128 bit, and these are the bit address of the bit addressable area. So the first bit is 00H. This bit is stored in the 20H byte address, and the last bit, that is 7FH, this is stored in the 2FH byte address. This address is incremented in upward direction. Bit addressable area are used by user. If user want to perform an 1 bit operation, so we use bit addressable area to store only 1 bit rather than using the whole byte. So if we want to perform any operation which is only required 1 byte or 2 byte, so we avoid the wastage of remaining bit in the complete byte, we use a bit addressable area. Bit addressable area are very useful when we want to store the status of a particular pin of any port, that is port 0, port 1, port 2. And bit addressable area is also used if programmer want to assign some function and this function required only 1 bit, so programmer also use bit addressable area. This bit can be used or accessed by using user-defined flag of PSW flag register. This is the PSW flag register. In this register, the pin number 5 is allotted for user-defined flag. So by using this bit, user can use or access the bit addressable area. Now the last area is called scratchpad area. It is also known as general purpose memory area. This area is 80 byte long. Its address starting from 30H to 7FH. Whenever the stack pointer area or the register bank area has filled, then data will be stored in the scratchpad area. This area are basically used to store results. This area are used to store series of data byte. This area can also be used to store the address, and this area also be used as a stack memory area. So we can also call this area as a high speed internal memory area. This area is used for temporary storing of data or calculations. Now special function register area. As I have already told, 8051 microcontroller having 256 byte of RAM, which is divided into two parts. First part is 128 byte of general purpose memory area, which I have already discussed. And the second part is called special function register area, which is also 128 byte long. So the address of special function register area is starting from 80H to FFH. These are the byte address or the physical address of the special function registers. So out of this 128 byte, 8051 microcontroller define 21 special function register. These register are basically peripheral related register, and each register having a special function associated with it. So it having only 21 special function register, and the remaining memory space is vacant. These 21 register is classified in many ways. So first, the blue background show the input output port special function register. These are port 0 register, port 1, port 2 or port 3 registers. The yellow background are control special function register, that is called T-con register, T-mode register. These two are timer or counter registers. Next is P-con register, S-con register, IE register, IP register and PSW flag register. The P0 register address is 80H. T-con register address is 88H. These are the physical address of these registers. Now the green background show the other special function register, that is accumulator register, B register, stack pointer register, data pointer registers, that is DPL or DPH register, timer or counter register, that is TL0, TL1, TH0, TH1 register and SBUF register. SBUF is a serial port register. All register are 8-bit long. For special function register, I have already made a separate video. If you want to detailed study of all the register and its function, please refer my that video. The link of that video I will give in my description box. So for special function register, please refer my that video. So this is the memory organization of 8051 microcontroller. Hope you like the video. Please keep watching my video and keep sharing my video with your friends.